Hello viewers, my name is Mohammed Toure. With me here you have Hadim Badi. So today we will be dealing with real number system. When you say real number system, what comes to your mind is what? Set of numbers. Set of numbers. In set of numbers we have natural numbers, whole numbers, integers, negative integers, rational numbers and irrational numbers. So today we have some set of numbers on the board, that is natural numbers. Natural numbers. The set of natural numbers are 1, 2, 3, 4, 5 and the like. It doesn't stop here. That is why we have this little mass. It continues. And it is denoted as the symbol n. Natural numbers is denoted as the symbol n. If you see the symbol n in set of numbers, it means it is a natural number. And secondly, we have whole numbers. Whole numbers, the set of whole numbers is 0, 1, 2, 3, 4, 5 and the like. It continues. That is why we have the data marks there. So the whole numbers, the difference between whole numbers and natural numbers is what? 0. Because in natural numbers we don't have 0 there. We have 1, 2, 3, 4, 5. But in whole numbers we have 0. 0 is included in whole numbers there. Because natural numbers, they are also called what? Counting numbers. And when we are counting numbers, we don't start it from 0, we started from 1. That is why in natural numbers 0 is not included, but in whole numbers it is included. And it is denoted as what? W, the symbol W. Whole number is denoted as the symbol W. If you see this symbol W, it means it is what? A whole number. So 3, we have negative integers. The set of negative integers are -5, -4, -3, -2 and -1. We can also say all the negative natural numbers are negative integers. All the negative natural numbers are negative integers. So fourth, we have what? Integers. The set of integers is -4, -5, -3, -2, 0, 1, 2, 3 and 4. So we cannot write all of them. That is why we put this data mark. It means other numbers are missing. The missing numbers are there. We cannot write all of them. That is why we have -5, -4, -3, -2 and 1. Now if you look at integers, now we can say integers is the combination of negative natural numbers and positive natural numbers. It's the combination of whole number and natural number, or negative natural numbers and positive natural numbers are what? Integers. So fifth, we have rational numbers. A rational number, the set of rational number is a number which can be written as a common fraction form. These are numbers that can be written as in a common fraction form. Now, in a common fraction form, example, if you have, let's say, 11/5, it's a natural number because this is a common fraction. So, but if you have 0/1, it's still what? A common fraction. It is a rational number. But if you have 1/0, it is not a natural number because this fraction is what? Is undefined. And when we are talking about the about rational numbers, we don't talk about undefined fractions. All the undefined fractions are not natural, are not rational numbers. That is, the example is given here. A/b, where b is not equal to 0. If b equals 0, there this fraction will be like this. It means A/0 is what? Is undefined fraction. Example, you have 1/2, -7/2, 23/7, -5/3. They are all what? Rational numbers because they are what? A fraction. They are in a fraction form. In the previous example, I told you that 0/1 is the same as what? 0/1 is a rational number. So here you have a fractions. Look at them. They can also be written in the form of A/b, where b is not equal to 0. Look at that. 1/2, -7/2, 23/5, -5/3. They are all rational numbers. And rational numbers, all proper fractions are what? Rational numbers. All improper fractions are rational numbers. All mixed fractions are rational numbers. All integers are rational numbers. Terminating decimals, they are all rational numbers. Current decimals are also rational numbers. Now look at the proper fractions. We have 1/2, 2/3 and 5/7. When we say proper fraction, this is where the denominator is greater than the numerator. If the denominator is greater than the numerator, therefore the fraction is said to be what? Proper fraction. Improper fractions, when the numerator is greater than the denominator, it is said to be improper. When the numerator is greater than the denominator, it is said to be what? Improper fraction. Mixed fraction. Mixed fraction is a combination of what? A whole number and a proper fraction. A whole number and a proper fraction is said to be what? Mixed fraction. Look at it. We have one whole number, 2 over 3. If you want, you can change this one to be in improper fraction. Example, if you multiply 5 times 1 is 5, plus 2 will be what? 7. So it means this is the same as 7 over 5. This is the same as 7 over 5. So this one also, 3 times 8 is 24, plus 1 is 25. So this one also is the same as 25 over 8. 3 1 over 8 is the same as 25 over 8. So we have integers. Integers are what? I said it earlier that integers are negative and positive whole numbers. All negative and positive whole numbers are what? Integers. So integers are also what? Rational numbers. Terminating decimals. All terminating decimals are a rational number. This is 5 over, this is 0.5, which is the same as 1 over 2. 0.5 is the same as 1 over 2. If you change it to proper fraction, this minus 0.731 is the same as minus 731 over 1000. 731 divided by 1000. This is the same as this in a fraction form. So these are terminating decimals. They are also rational numbers. So we have recurring decimals. All recurring decimals are rational numbers. All recurring decimals are rational numbers. Now we also have irrational numbers. Irrational numbers, these are numbers that cannot be written in the form of a common fraction. These are numbers that cannot be written in the form of a common fraction. For example, root 3 is an irrational number, and pi as well. Pi also is irrational. Look at it. Take note. The value used for pi, such as 22 over 7 and 3.142, are only approximations. Yes, 3.142 is an approximation. Just take a look. The value, the original value is 3.141. The next value is what? 5. Because it is what? It is non-terminating decimal. The pi is non-terminating decimal. So it's 3.141. The next value is 5. So that is why they approximate. If you approximate, it will be 3.142. It is not 3.142. It is not exactly 3.142. It is an approximation. Now note, all non-terminating decimals and non-repeating decimals are irrational. All non-terminating decimals and repeating decimals are irrational number. Note, when an irrational number is written as a decimal, the decimal is infinity, meaning it continues, it goes forever. It has no repeating pattern. It means it goes forever. When an irrational number is written as decimal, the decimal is infinity. But a rational, it is not infinity. But irrational, it is infinity. It has no repeating pattern. So, take note again. The square root of a prime number is irrational. The square root of a prime number is irrational. Prime numbers are numbers that has only 2 factors, itself and 1. Example, we have 2, 3, 5, 7, let's say, etc. So see these numbers. The square root of these numbers are prime numbers. The square root of these numbers are prime numbers. Example, root of 2, root of 3, root of 5, and root of 7. All these are irrational numbers. All these are irrational numbers. And note, the product of 2 irrational numbers is also irrational. The product of two irrational numbers is also rational numbers. Example, if you have root of 3 times root of 3, this is root of 6, root of 2. So this is root of 6. And root of 6 is irrational. If you take your calculator, you punch it, it is irrational. Root of 3 multiplied by root of 2 is irrational. That is why it is said that the product of two irrational numbers is also irrational. The product of two irrational numbers, it is also irrational. So let's try to solve some examples in rational and irrational. So let's try those examples and see whether we will be able to identify rational and irrational numbers. Okay, let's try to solve this example. So example 1, sort out the following numbers in the rational and irrational given reasons. Now A, we have 0.325, B, we have 0.66 infinity, 0.090909 up to infinity, 0.732333434 and 55 up to infinity. Now if you look at A, B, C and D, now we are going to identify rational and irrational. Now see, A, if you observe A very well, it is not an infinity. If you look at B, it is infinity. Look at this. It is non-terminating, non-recurring decimal. Look at it. Non-terminating, non-recurring decimal. Look at it. So if you look at this one also, you have non-terminating and recurring decimal. Non-terminating and recurring. This is non-terminating and recurring. Non-terminating and recurring. This is non-terminating. This is a rational number because it is not a recurring number, but it is a terminating decimal. And we said all terminating decimals are what? Rational numbers. It is a terminating decimal, but it is not a recurring decimal. But all terminating decimals are irrational numbers. This one, it is non-terminating and recurring. It is a non-terminating decimal, but look at it, it is recurring. This one also, it is non-terminating, but it is recurring. And non-terminating decimals are rational, but all recurring decimals are irrational. So that is why it is said to be irrational, because it is recurring, repeated. It doesn't stop here. This one also, it is repeating 09, 09, 09. This one also 666 up to infinity. This one also 666 up to an infinity. This one also is 0.7323. Look at the pattern. The pattern is not repeating, and it is non-terminating. Therefore, it is irrational, because it is said in our previous explanation that all non-terminating and non-recurring decimals are irrational. And this one, it is non-terminating and it is non-recurring, so it is irrational. So A, you can say 0.25235. This is rational. Reason. It is what? Terminating decimal. Terminating decimal. That is A. The reason for A is it is a terminating decimal. It is a rational number. Reason is terminating decimal. Then B, we have 0.666. So see, this is also a rational number. Reason, it is non-terminating. Non-terminating, recurring decimal. It is non-terminating recurring decimal. It is repeated. Look at it. It is non-terminating and it is also recurring. So therefore it is a rational number. C also is a rational number, but D is irrational. D is irrational. Reason: it is non-terminating, non-recurrent. And non-recurrent. Non-terminating, non-recurrent decimal. That is why it is said to be irrational. So therefore, A, B, C, they are all rational numbers. Then D is irrational because it is non-terminating, non-repeating decimals. Example 2. We are coming to solve example 2. Sort out the following numbers into rational and irrational. Now see the examples A to G. Now we have 3.222. We have 222 also. It is what? Look at this. It is non-terminating and it is repeating. Non-terminating recurring decimal. A is non-terminating recurring decimal. Therefore, look at it. It is a rational number. Now B. Look at B. We have 16.213489. Look at this. It is a non-terminating decimal, non-recurring. Look at it. Non-terminating, non-recurring is what? Is irrational. Look at it. It is not repeating. So it is irrational number. So look at letter C. We have 0.431. 431. 431, 431. It is what? It is irrational because look at the pattern. It is repeating and it is non-terminating. Meaning it is infinity. Look at it. It is infinity. Therefore, 0.431, 431, 431, it is a rational number because it is non-terminating recurring decimal. Therefore, it is a rational number. Now D, 0.41285, 0.142857142. So D also is what? Is a rational number. Look at it. D is a rational number. It is non-terminating. So it is a rational number. Now E, minus 18.191, 191, 191, then you have 191. It is also non-terminating, but it is non-recurring because the pattern is not going well. From here to here, the pattern is going fine, but the time we reach at 111, the pattern changes. It means we have 19919, 191, 191, 191, but here the pattern changes to 11. So therefore, it is not a rational number, but irrational. Means letter E is irrational because it is non-terminating, non-recurring decimal. So let's go to letter C, letter F. Letter F we have 0.090, 909, 090, then 909 again. Look at it. This is non-terminating recurring decimal. We have 909, 090, 909, 090, 909. It is repeating. The pattern is going fine. Therefore, this is non-terminating recurring decimal. Therefore, it is said to be what? A rational number. Letter F is a rational number because it is non-terminating recurring decimal. It is recurring. The pattern is repeated. So let's go to letter G. Letter G, 223, and we have 333, 343. Look at this. It is also a non-terminating because it doesn't stop. It is also a non-terminating, but it is non-recurrent. Look at it. It is non-recurrent decimal. We have 313, 323, 333. We have three different numbers there that are not the same. Three patterns that are different. Look at it. So therefore, it is said to be non-terminating, non-repeating decimal. So that is said to be irrational numbers. So this is all what we have for you for today, and this is the first lesson for number system, and we will be dealing with others like approximations and that is round up, round down, and the others. we will be doing that in our next episode. So if you don't subscribe, please try to subscribe, bust the notification bell so that you'll be notified of any of our videos uploaded in YouTube. Thank you all for your kind attention.